Hi, welcome to Chapter 12. Chapter 12, we're just going to barely cover it. I just want to give you a little bit of exposure to it. We're not going to spend that long on it. But Chapter 12 is something called recursion. And so we're going to talk about recursion. We're going to talk about we're really just going to cover a couple of examples, and that's all we're going to cover for Chapter 12. So what is recursion? So recursion is basically a function that calls itself. Recursion function must always have a way to control the number of times it repeats. So what it's saying is, when you call yourself, you keep calling yourself, you've got to have a way to get out. It's kind of like a loop. I'm not going to really say it's a loop because it's not really a loop, but in the sense that's kind of like a loop in that you have to have a way for it to get out. It's usually going to involve some type of an if-else statement, which defines when the function should return a value and when it should call itself. Depth of the recursion is how many times the function calls itself. So I want you to think of it this way. When it calls itself, they call it the stair step, because what it does is when you call the function, it's going to call the function. So another version of the function is now running. This old function is still running as well. And then the next function calls itself. So think of it. It calls the function, and it calls a new version of the function. It calls a new version of the function, calls a new version of the function, and calls a new version of the function. It's going to have to come back to this one. It's got to come back to that function. It's got to come back, got to come back, got to come back in order for it to basically end the entire process. Here's kind of an example. They basically say, here's recall. So the name of this function is called message. And if times is greater than 0, we're going to print this is a recursive function, and it's going to call itself times minus 1. So we're going to pass in the number of times we're going to basically do this. And so a recursion is kind of like a way to do a loop without really doing a loop. So let's actually take a look at some examples. Now in the book, the very first thing it covers is this one called the recursive, and this is basically, is that it? No, I'm sorry, it's called endless recursive. So this is an endless recursive, meaning it's just like an endless loop. So here I've got main calls message, and then message basically prints this as a recursive function, and then it calls itself again. No way to get out. It's just going to keep calling it, keep calling it. So when this runs, it basically says, hey, this thing ran more than 995 times, and it basically errored out. So so you see it ran a long time before it blew up. So let's take a look at recursive now. So here we have recursive. And in the main, it calls message and passes the number 5. So in the message, it's going to bring in times, and it says if times is greater than 0, it's going to print this as a recursive function, and it's going to print message times minus 1. So now it calls itself. Now remember that old message, the old version of this message function is still running, and it calls a new one. And it calls the new one and calls the new one. You'll see what I mean here in just a second. So when we run this, it's going to look like it basically ran it. Let me expand this up a little bit. So it ran it 1, 2, 3, 4, 5 different times. But what I want you to do now is I'm going to do this, is I'm going to print I'm back from the call. Okay. So now when it runs, so basically it calls and prints this message, and then it basically after it runs the message, it has to. So this doesn't run until it's actually back from the final call. So probably not a very good example, but it's so kind of again going back and looking at this item. So when this first call of the function happens, it displays that print message, and then it calls the next one, displays that print message, calls the third time, Okay, so think of it. It's now got that message function open. It calls it again. That message function is open. Calls again that. So again, these are still open. These guys are still open up here. So when it finally gets down to where, again, we have to have a reason to get out. This way, it basically subtracted from that variable, so that it basically finally gets us back. And then it basically, once it's done with this last function, it has to go back to this function, which is still open. Really does nothing. This one, this one, this one, and this one. So, so my example over here, you'll notice that it's got recursive function, and then it's got these separate. Now, the way it should have, the way you would look at this is, you would think this would print, then this would print. No, because it basically runs this. This is a recursive function. It calls the message again, which comes back around and says, is the times greater than 0? It still is. It prints that message again. Then it calls it, prints that message. Okay, so it never gets to this other print until it's done with the recursive process. Then it prints that. It goes back to the previous version of that function that's open, and it prints it again, prints it again, prints it again, prints it again. Now, if this was a loop, we would have, this is a recursive function, I'm back from the call. They would be alternating that. So, again, I like how the book basically says, recursive is a powerful tool for solving repetitive problems. Recursion is never required to solve a problem. Any problem that can be solved recursively can be solved with a loop. Recursive algorithms are usually less efficient than iterative ones due to the overhead of each function call, meaning that when you call a function, that function's still open. When you call another version of it, another version, those are still open. And it's kind of hard to get your head wrapped around it. So again, that's why this is all I want to cover for this chapter. I just want to kind of get you some exposure to it, just so that you have just a little bit of knowledge on it. Again, we're not going to have any homework assignments, but this is all we're going to cover. So, okay, we'll see you on chapter 13.